Hello guys, welcome back to my channel Need Dost. Before starting this video, if you are new to this channel, please subscribe and switch on the bell icon for quick notifications. So let's start this video without any delay. In today's video, we are going to discuss about atomic physics. It's a simple and mark securing chapter in physics. It has a weightage of 1 or 2 questions. The second question will be application to other chapters in final NEET UG examination. In today's video, the first topic is Rutherford's alpha particle scattering experiment. And first, in this experiment, the main point is nucleus was discovered by Rutherford. Please don't confuse it with Chadwick. Simply remember Hello guys, welcome back to my channel Need Dost. Before starting this video, if you are new to this channel, please subscribe and switch on the bell icon for quick notifications. So let's start this video without any delay. In today's video, we are going to discuss about atomic physics. It's a simple and mark securing chapter in physics. Hello guys, welcome back to my channel. Video. If you are new to this channel, please subscribe and switch on the bell icon for quick notifications. So let's start this video without any delay. In today's video, we are going to discuss about atomic physics. It's a simple and mark securing chapter in physics. It has a weightage of 1 or 2 questions. The second question will be application to other chapters in final NEET UG examination. In today's video, the first topic is Rutherford's alpha particle scattering experiment. And first, in this experiment, the main point is nucleus was discovered by Rutherford. Please don't confuse it with Chadwick. Simply remember, nucleus was discovered by Rutherford. And in alpha particle scattering experiment, we all know he had sent many thousands of alpha rays through a gold foil, and he found majority of the alpha rays has passed without any deviation. Only few were deviated, and exactly one of the ray came exactly opposite to the initial path. This is the peak. Majority of the alpha rays has passed without any deviation. Only few were deviated, and one came exactly opposite. This is the whole scenario of the Rutherford's alpha particle scattering experiment, and the conclusion given by him is most of the atom is empty. Next subtopic is distance of closest approach. Here it is related to the ray which is deviated exactly. Initially let us assume it is traveling in straight path. It has reached near some element or some atom, and it is reflected. Up to which extent it has been traveled. See, initially it has come like this, and it has reached certain distance. By this distance it has moved back. It did not travel this distance. It did not go near. It reached certain distance that is close to the nucleus. Finding this distance is called as distance of closest approach. This is an atom, this is the atom's nucleus, and this is the closest approach. To find that, simply you are using the law of conservation of energy. Potential energy plus kinetic energy initially is equal to potential energy plus kinetic energy final, law of conservation of energy theorem. Remembering this solves many of the questions, but without any time waste, we need to find that. So we are following this process. Initially, it has potential energy 0 and it has initial velocity u 1 by 4 pi epsilon naught ze by r square, because it is the finding the energy by using electric potential energy, plus finally it has zero kinetic energy because it is simply repelling back. By solving this equation, we will get r equals to distance of closest approach. By this, if they ask to find the volume of the nucleus, simply we will use 4 by 3 pi r cube. It will be approximate, not exactly. Here we need to find R based on this relation, potential energy plus kinetic energy initial equals to potential energy plus kinetic energy final. Finally, volume of the nucleus is approximately 4 by 3 pi r cube. Another Rutherford's alpha particle scattering experiment for particles scattered at an angle theta, simply represented by F. This topic is mainly needed for AIIMS, and as we know, NEET and AIIMS are mixed as and considered as a single exam. We may not know whether it will be given or not, but let us keep an eye on this. Simply, we need to remember this formula F equals to nt pi b square. I am going to describe this. F is the fractional number of alpha particles scattered at an angle theta. N is the number of atoms per unit volume of gold foil. P is the thickness of gold foil. B is the impact parameter. B equals to Z1 Z2 E square by 8 pi epsilon naught square kinetic energy into cos square theta by 2. You need not to remember this. By seeing this formula, just don't get panic. We have simple relations. Just remember this. They will give directly the impact parameter value. So simply we'll substitute here. For idea, I am saying the impact parameter formula Z1 Z2 E square by 8 pi epsilon naught square kinetic energy into cos square theta by 2. Remember only this formula. F equals to nt pi b square. Here again I will recall this once again. Simply remember this formula F equals to nt pi b square. The terms in it are F is the fractional number of alpha particles scattered at an angle theta. N is the number of atoms per unit volume of gold foil. T is the thickness of gold foil. Pi all its constant we know. B is the impact parameter. Coming to another subtopic of Rutherford's alpha particle scattering experiment is number of alpha particles scattered at an angle theta. These two are interrelated, but this is different question. This will be different question. Here, let us assume n theta means number of alpha particles scattered at an angle theta is equals to number of incident alpha particles into t means time by 16 into z1 z2 e square by 4 pi epsilon naught k into 1 by r square sin power 4 theta by 2. This is the formula for number of alpha particles scattered at an angle theta. Friends, simply don't mug up this formula and don't become tensed or panic by seeing this formula. We need not to remember this. Simply we need to remember only one, that the relation n theta is directly inversely proportional to sin power 4 theta by 2. Sorry. We should to remember n theta is inversely proportional to sin power 4 theta by 2. Just remember this relation and this formula. So we are done with this. And to derive, here is one important note point. Here we are seeing that alpha particles are projected in this way. Alpha particles are